All right, so today I'm just going to do a quick little video here, kind of off the cuff. We just released the MKS Monster 8 V2 in our store. This is a board from one of my favorite Chinese board manufacturers, and we've sold their stuff before. And for you guys that are the DIY type, these are the boards that you guys have been asking us for. Now, it's not really cost effective for us to design our own, so we went out and searched for these type of boards to sell, and here they are. Now, accompanying that board, when you purchase this from us, and we do have the firmware available separately if you ended up purchasing from somewhere else, I spent a lot of time getting our Unify 2 running on it, and this is what's called a DIY firmware. And what that means is it's a guided setup to walk you through all your settings. So I will be, if you guys want, this is a live video, there will be a replay. If you guys do want to ask questions about the MKS Monster 8, I'd be happy to answer them for you, but we're going to keep the questions on topic there. But I'm going to go ahead and pull up a copy of the actual firmware that you get so you guys can see what the firmware looks like, so you can see what you're getting yourself into. One of the other things I am going to show here, and this is included with the firmware package, is a case that Tor actually designed for us. So this is just a general 2020 extrusion case here that we designed for the Monster 8. You can see here we've got some zip tie holes to retain the cables, so you just loop it through the bottom and you can tie the cables down once you get everything in. They got the full 4 bolt holes here for the board itself. We got a little access port here for the SD, the USB, the USB port for like a flash disk. This board does have a flash disk support, so you can like print off of a USB drive, not just an SD card, as well as a USB-C to actually have a serial connection to, your computer or Octoprint setup or whatever. Now, MKS does officially support Clipper on this. We aren't doing official Clipper support because Clipper is a very complicated firmware, but we do have our Unified 2 firmware for this, and that's included. We got the CAN bus open here for those of you guys that want to actually use it with a CAN bus setup. That's something that's not in our firmware right now. It may be added later, but I'm just going over what we have for you guys now. In addition to this nice case, we also have little holes here. This is for our V3 MOSFET that we carry. So if you are running like a 12-volt printer, a CR10 where it's going to have a higher amp draw, I definitely recommend getting the separate MOSFET, because during my testing with a 13 to 14 amp load, the onboard MOSFET, while it did work, it did run pretty hot. Now, for you guys that have the EasyABL, this back here is so you can just take some two M3 screws and bolt your EasyABL control board to the back of this enclosure. And then the enclosure does have a lid here. I just had it hidden, and the lid has spots for two 40mm fans. So you can bolt the two 40mm fans up to the top here, and this goes right over the drivers. So now if I go ahead, I'm going to go switch over to the actual board itself here. So I got it in my light box, so it's all nicely lit up. And we're going to go over all the different stuff on this board. So when you guys buy this from us, you will get 8 drivers. You're probably not going to use all of them, but we're bundling you with all the drivers you could ever want. Now, right now I have 6 drivers populated, and we do have different pictures showing you guys what you should put where depending on your setup. So for example, if I'm just running a printer that just has 4 drivers, so X, Y, Z, and E, that's all you'll have. If you have a printer that's going to have 2 extruders, you would just pop a 5th one in here on this driver position. If you have a printer that's single extruder but has 2 Z motors and you want to run them independently, you would populate it like this. And if you're doing dual extruders with dual Z, you would have 6 drivers. Now, like I said, this board does support 8 drivers. The other thing we do have on the site as an add-on for this is what's called the 3MOS module. And this module will actually work with any board that has socketed stepper drivers like this. And this little guy gives you 3 more MOSFETs. And typically, these are going to be used for fans. So each of these little outputs will handle up to 2 amps. And you just line these up here so you can see they're color-coded on the sockets here. So you just line this up here, and I'm going to actually put a predefined thing in the firmware, so when you pop this into the 8th position, you now have 3 more fan outputs. And this is going to take whatever is the voltage input. So if you put 12 volts into here, 12 volts into here, you're going to get 12 volts out of the fan header. If you put 24 in, you're going to get 24 out of here. Now, this does have 6 fan outputs. 3 of them are controllable, and 3 of them are always on. And if we zoom in here, you can see here, these first three here, these are always on fan headers. And these last three here, these are controllable. So from left to right here, we have always on, always on, always on. This one is your hot end fan. So I'm going to get a screwdriver here to point out this because my fingers are big. So this is the fan that's on your hot end that cools the heatsink. This one is for your controller fans, so the ones that would cool your control board. And then this one is your layer fan. And if you notice here, we've got jumpers on all of these. So you see it says VIN, and then we have 12 and 5. These are so you can run different voltage fans off of these headers. So let's say your hot end fan that's cooling your heatsink is a 12-volt fan, but you're running 24 volts. You can actually just move this jumper up. Hang on one second. You can just move this jumper up to this position here and it'll go to 12 volts. Similarly to like those, I know there's some people that like the Noctua fans and those come in 5-volt flavors. You also have 5-volt options. So this actually has multiple step downs on here to achieve that. So this is, I believe, if memory serves correctly, this is a 12-volt one, and then they have actually 2 5-volt ones. So one 5-volt one to run your fans and also your NeoPixel ones. And it amuses me that the silkscreen, it's NeoPixel. But it does work really well, and everything's clearly labeled. I do like how well they labeled everything on here. So you've got 3 controllable fan outputs by default. You also have 3 hot end outputs. And the nice thing about these two, if you know how to edit firmware, you can actually repurpose these other 2 hot end outputs to be additional fan outputs. So for example, if you only have a single extruder printer, you will only be using the HE0, which leaves you 2 more outputs. So you could use these for fans, you could use these for lights, you would just change the pin. And we do have the pins file listed on the documentation page. The other thing here on the drivers here, since the bundle includes the TMC 2209s, these are what are called UART drivers, UART capable drivers. That means you can set the stepping mode, you can set the voltage or the current going in the motors all digitally through the firmware. So that's what we're doing. And all you need to do to enable that is put the jumpers in the position here. And there are pictures of this on our site. The other thing I also like too, and they put a lot of thought into this board, which is why we're carrying it. I really like it. So you have our driver 0, so this is your X, this is your Y, and if you notice here, we have driver 2-1 and 2-2. So these two are actually coming off of this third driver. So if you have a printer that you don't want to run dual Z on, and you just want to have them off of one motor, maybe you're running it linked with a belt, and you don't care about having, you know, the auto leveling with the gantry, if you have an auto bed leveling sensor, you can actually run 2 motors off of this one output here. It's basically a built-in dual Z splitter. And then if we go down here, you notice they started 0, so driver 0 through 7. So going in a line here with our firmware, you have X, Y, Z. So this is your first Z driver, and then your E0, which is your first extruder, and then E1, which is your second one if you run a dual extrusion. And then driver 5 here will be your second Z motor. So we've set our firmware up to map all the pins to go to these correct headers. And then as of right now, 6 and 7 are not being used. And once we release an update for the little 3MOS module here, it will be set up to go in the very last spot here to give you 3 more fan outputs. So we do have these on the site right now. There's just a lot of flexibility with this board. So I use this board on a custom build here, and I didn't want to use end stops, and this actually supports centralist homing. So if you see here, this driver diag header, drivers 0 through 5 actually support centralist homing. Now, most people are only going to use it on X and Y. So X is 0 and Y is 1. So you'd put a jumper on these for whichever axis you want to home with centralist homing on. Hang on one second. Sorry, the dogs got put in my office when I wasn't expecting them, and they are being very loud. Okay, so going back, where are we at? Okay, we're talking about the sensorless homing. So you can either use sensorless homing or you can use end stops. So we have X, Y, and Z end stops here. We have the Z plus, and then we have MTDET, which stands for material detect. So this is your filament sensor. Now, if you're running dual extruders, I have the firmware set up so you can use the Z plus and the MT detect. This would be for your first extruder, and this will be for your second one. So you can actually run dual filament sensors on here. Obviously, we've got a NeoPixel header here, so if you're using like our Easy Neos, you can actually drive them right off of the pins here. and they do have the G, S, and 5V labeled. The G is your ground, the S is the signal, and the 5V is your 5V. You also have a 3D touch header here, which would be for like your BL touch. So you got a signal pin, a 5V, and a ground, and then the other two Z signal wires would go to the Z minus here. So, and these are also labeled here. So you see there on the PCB, they did a lot of labeling. So you got your voltage, ground, and signal. Now, if you guys have end stops that only have 2 wires, which is common on a lot of machines, you'll want to hook up to the ground and the signal on these and not use the voltage output on the pin. So basically you just use these bottom 2 pins here. The other thing is here, so you have your LCD hookup. So if you have a 128/64 screen, these are what you would use. Now, in our firmware, we actually wrote the pins to be able to use the single cable Creality LCD ones. On the EXP1 header, you would just put the cable in backwards. I'll grab a cable and show you what that is so it makes sense. So basically, if you have a keyed cable here, obviously it's going to go in like this normally, right? You put the key in to match up with the keyed spot on the socket. Sorry, my autofocus is not playing nicely, so that goes in like normally. Now, if you're running the Creality screen with the single cable, you would just flip this around 180, and then just force it into the header like this. It will push the back of the plug out, but this works perfectly. So you actually don't need any adapters. I think that just about covers all the stuff on here. It does have some nice beefy terminals here. We got dual fuses here. One's for the main board and one's for the bed. These are our power inputs. And again, they labeled on here the positive and negative. So these are your power inputs. And these are the bed outputs. And if we flip the board over, they actually put even like all the pin numbers for most of the headers are all labeled on here. So these are all your pin numbers. So if you ever have been doing stuff, it's like, well, I need to know a pin number. It's actually on the board itself. So you can just look at the board here, and they even label like the fan outputs here. So you got PA0, PA1, and PA2. Same thing for the heat bed. It's on PB10, and this is our main power input. So again, lots of attention to detail on the actual board itself. A lot of good quality component selection on here. MKS is one of the few companies I like that actually knows how to make a decent board that's affordable, that doesn't cut corners to the point where it becomes very unreliable. Like, we've sold these for a while. In terms of the brand MKS, we've sold MKS in the past. We've never had a dead on arrival board from them. So I'm very happy to be carrying these. I hope you guys enjoy this. I'm going to run through the firmware really quick, and I'm going to check the chat. I think the only other thing I didn't point out here is there is actually, if you guys notice right here, see this 5V? This is actually a 5-volt output, so you could power like a Raspberry Pi or a 5-volt SBC from there. So let me go ahead and I'm going to pull up the firmware so I can show you guys what that looks like. Because a lot of people that just want to use their printer, they want to pop the board in and get up and running pretty quickly. You know, they're not going to want to be messing around with having to do, you know, all sorts of different stuff just to get the firmware working. The funny thing is, with the stock Marlin setup, they actually do not even support dual Z drivers. I actually had to modify the code to get that running. The stock setup is assuming you have a ton of extruders. I don't know why. But with our firmware, we did a lot of customization. So in the actual firmware here, we've got a bunch of notes here, like what kind of LCDs, the Creality LCD with the single cable connection like I covered. We've got the different notes here for the stepper drivers. Like I was going over, driver 0 is X, driver 1 is Y, Z is the first one, and so on and so forth. So there's just a bunch of notes. So I put a lot of information in the firmware, so you don't have to keep going back to the documentation page unless you really want to. We've got our LCD set up here, so it's going to give you the option to set the single cable CR10 style LCD. That's the Creality one. So if you're using that, you would just uncomment this. And then you've got your different bed sizes. So you'd put your X and Y bed size in here. And then we start getting into configuration of the actual motors. So I recommend just leaving these stock, and then flash the board and then see what moves the correct direction. You get, again, there's directions in here. So basically, if you're X, you tell it to move, you know, to the left and it goes to the right, you would come in here and change this from a false to a true, and then reflash the firmware. Same thing here for the end stops. You can do a test. Let's say you press the end stop and it's showing open instead of triggered. Let's say my X is backwards. I would just go in here, change it from a false to a true. So it's a whole guided setup. We also support homing to the min or the max on your X or Y. The firmware is set up so the Z always homes to the min. There's not many printers that home to the max. So that's not in there right now. I could add it on later, but we haven't had any requests for that with other DIY firmwares we put out. We have then now your steps per millimeter, so your X, Y, Z, and E. If you're not sure what those are and you're upgrading an existing printer with this board, you can send an M503 on most boards, not all of them. It depends on how their firmware was set up. If you're using our firmware, like you're going from a stock board with our firmware to this one, our firmware will spit out the M503 on most of the builds. I think just on some of the 8-bit boards they don't. But these are good baselines. So most printers are going to run 80 steps per millimeter on the X and Y, 400 on the Z, and then most of the basic extruders are 95. But you can set whatever you want in here. Again, if you're not sure if it's moving too far or too little, you can tell it move, 100 millimeters or move 10 millimeters and measure to see how much it actually moves. So if it's not moving enough, you would want to increase your steps. So let's say my X, I told it to move like 10, it only moved like 8. I can assume I'm going to need more steps per millimeter. So maybe it's 100 instead of 80. So you can have full control over setting all these options. This is an optional setting. If you don't set anything here for your acceleration and jerk values, the firmware is going to take your bed size and make a good guess, a conservative guess of what your acceleration value should be. So this is optional. Basically, if you uncomment these lines here and put your own values in, it will then override whatever the firmware is going to do, but it's optional. Got all sorts of thermistor settings. So we've got the thermistor settings for the first hot end. We also have where if you don't set anything for the thermistor for the second hot end, it's going to use whatever you use for the first extruder. So if you're running a dual extruder setup. So you can run, let's say you have one that's got a high temp thermistor, one that's not, you have full control. You can set whatever you want here. We have settings for the bed. We have settings for the baud rate. This is another important setting depending on if your printer is running on 12 or 24 volts. It adjusts certain timings in the firmware. We also have good baseline current settings. So this board is controlling the drivers and how much current they're giving the motors through the software. These are good baselines for most machines. You can either set it in here or you can even tweak it through the LCD. We have other options here for, like I was talking about, running 2 Z motors. So if you have a printer that's got 2 separate Z motors, you can actually drive those independently. And if you have an auto bed leveling probe like a BL Touch or Easy ABL, you can actually use that to level the gantry out. So the firmware is going to automatically enable what's called G34, which is the gantry auto leveling, if it detects that you are running dual Z motors. So if you tell it here, I have dual Z motors, it's going to assume that there's going to be that second driver installed and your stepper that's on the right side of the printer is hooked up to Z2, which is driver 5, and your other one's hooked up to Z1, which is driver 2. And again, if you have an auto bed leveling probe, G34 will automatically be enabled. You don't have to do anything else. You don't have to use it if you don't want to, but basically if the two requirements of telling it you have 2 motors and you have an auto bed leveling sensor on there, whether it's a BL Touch or an Easy ABL, you'll automatically have the G34 enabled. Now, let's say your one motor's running backwards, and it's making the gantry tilt. You would want to get the general direction set by the actual Z direction here. So it goes based off of the master one, which would be the Z1 driver. So basically you want to see if you have 2 Z drivers, let's say you tell it to go up, it goes down. You want to change it here. And then let's say, well, now instead of it, it's going correct on the left driver or on the left motor, but it's going wrong on the other one, you would then come and uncomment this here and it would invert the direction on the Z2. So I've tried to account for all sorts of different scenarios. We also have, this is one of the first firmware releases where we actually have full settings for the LDO Orbiter V2 filament sensor. Whether you want to just use it as a basic sensor, you can just uncomment this here and hook it up to the MT detect header. Or you can also do the filament sensor unload. So if you uncomment this and tell it what pin it's on, remember we were talking about the pins on the back of the board, how I like that they labeled them. This is where you would get it. So by default, PA8 is actually the BL Touch header. If you're using an Easy ABL, that header is going to be free because we don't use that. We just use the Z stop. So that's what I'm using, and that's why I figured it would be a good example. So, but if you don't want to use that, you just don't hook that pin up. And it also supports our other just standard easy out sensor. So, if you just got our standard easy out sensor, you can tell it that, or hey, you got two of them, you would uncomment that one instead. So trying to account for all these different things, and this firmware will be updated. We will be, if there's any features that you'd like to see in here, we will be adding different things on as we release firmware updates. So this is just the initial release. This is the first public release for this firmware with this board. We also have a ton of example ABL probe mounts, depending on what printer it's on. This board can go in any printer. It's just, you got to figure out how to mount it and do the connections. And this firmware is going to help you get everything set up. But just like all of our other ones, we also support custom probes. So if you're not using any of these example probes, maybe you got a micro Swiss on there, maybe you got like a Hero Me or whatever, the custom probe option is still in here for the Easy ABL, which the BL Touch also uses as well. Going down here, we get into the dual extrusion settings. So if you are using a dual extrusion, whether that's two separate hot ends on one carriage or a single into one, we've already accounted for all that. So we've got your motor direction here. And again, it's going to assume that if you don't set anything for the second extruder, it's going to just use the same settings as the first one, if that makes sense. So you would just tell it, hey, I've got a dual extrusion set up, and that's all you need to do. By default, it's going to assume you have two hot ends. So if you have two hot ends, you also are going to want to probably tell it the offsets in relation to the first hot end, which we have options here. So the first value here is your, oops, didn't mean to move that. Your first option here is always going to be 0, 0, because that's E0, or your first extruder hot end setup. And then the one on the right here in this array is going to be the second one. So you just measure, nozzle to nozzle. Typically, there's not going to be any offset on Y, but you can set different offsets. And typically there's not offsets on Z, but we have it in here since Marlin does support it. The other thing too is if you're running a 2-into-1 setup, so you got a Y splitter, which I've messed with all sorts of dual extrusion setups with, two hot ends with two separate nozzles. I've also messed with ones where they have like a Y, where it will combine them into two. And we also have that as well. So if you're one of those people that has a hot end that mixes the colors, or, does a change where it retracts, so you have your slicer retract the one extruder that you're printing with, and then it extrudes the other one, this will also support that as well. So I've been trying to account for all sorts of different scenarios and stuff. And then we have, if you guys have used our firmware, we got stuff that's very similar and familiar to you. We got PID settings, our Easy Neos. We also have different Core XY settings, so if you're putting this in a Core XY printer, and then also the extra fan output. So when I was going over earlier, the different fan outputs, fan 1, you can have this to be your controller fan, so that'll cool the board. Fan 2 will be your hot end fan. So basically all those fans can turn on and off and just have the board do it by default. And all you have to do is hook them up to the correct header and tell the board you're using it. So yeah, there's a ton of settings in here. We also got input shaping in here if you want to play with that. Basically all of our other standard options that you're used to seeing with our unified firmware. Like I mentioned earlier too, you have sensorless homing. So if you're, let's say you don't have an end stop on X, you want to use a sensorless homing, you can tell it, hey, I'm using sensorless homing here by uncommenting that. And then I would recommend just starting with this calibration value of 75. That basically is a number you're gonna have to play with by testing and homing and seeing if it's registering that the axis is hitting, the printer where in the direction it's homing. Sometimes you have to raise it, sometimes you have to lower it. There's no way to be like, hey, I can't be like, you need to set it for this value for this printer, because it has to do with belt tension, has to do with the weight of the carriage, and the setup, whether it's on the bed or the X, so on and so forth. So, but it does support sensorless homing. You can adjust this value here from the LCD of the printer screen. Usually what I'll do is I'll mess with it on the screen, figure out what my values are for X or Y. On my other build, I actually use sensorless homing for both axes, so I figured I ended up with a value of 78 for my X, and I think like 120 for my Y. And then I put that in the firmware, so that way, anytime I reset the EEPROM, those settings stick. Just like all of our other firmwares, we have options here for adjusting the home offset. So basically, if your nozzle's homing off the bed, you can tell it what that is. We've also got different overrides for like the sending your BL Touch pin. This one will be defaulted to the PA2. And then we've also got manual mesh leveling if you don't have a probe, and linear advance and all the other fun stuff. So I was about to say something about the bed override, but in this firmware, this is assuming you're entering a bed setting, so it'd be kind of redundant to have that. So, but anyways, I hope this gives you guys an idea of all the stuff we've put into this firmware. Overall, I'm very happy to be offering this board as a nice DIY option to complement all the other boards we have. So if you guys want to pick up an MKS Monster 8, we're selling them right now. The bundle includes the actual board itself, 8 of the drivers with the heat sinks, and it also comes with a USB-C cable as well. So, and if you also purchase it from us, whether you get just the firmware, maybe you already bought this board from somewhere else, if you purchase the firmware with the technical support, or you just buy the board from us directly, you do get technical support. So if you got questions like, hey, how do I wire this up? Do I have my end stops right? You know, we can help you to make sure you don't short anything out or wire things incorrectly. So anyways, I hope you guys enjoyed this video. I hope you guys like these boards. I'm really excited to do some builds. I'm kind of itching now to do more custom builds since we've got these boards with all these different bells and whistles and options and pins. And I will see you guys on the Wednesday stream. Sorry about the interruptions here. I just want to do a quick little video to go over this. Spent a lot of time this weekend getting everything ready for the launch. And again, if there's certain features that you'd like to see in the firmware that you're one of our customers, go ahead and send us a message. You know, worst we can do is say no, or a lot of suggestions when we're doing revisions of things is we'll note them down. And if we get, you know, if it's something quick, we'll usually do it. But if it's something more involved, we'll usually note it and be like, okay, well, we've had 10 people request this. We'll do it. You know, or if it's a fringe use case, we'll be like, hey, here's how you can modify the code to do what you want. So, because we do give you the full source code. So anyways, I will see you guys on the next video. And as always, happy printing.